Okay, so now we'll move on to the next part of the lesson, mean and variance of the binomial distribution. Okay, so when it comes to the mean and binomial of the distribution, the rule is given here. If x is a binomial random variable with capital X follows a binomial distribution n comma b, then the mean of x ex is given by np. I think you can remember mean and variance was also discussed in S1. Do you recall? So mean is basically the average or like the mean, basically the mean value, right? The average. And variance is how much we use the best version we use is standard deviation. Standard deviation is the square root of variance. Do you recall? And standard deviation shows how much your data is spread around the mean. So these are the definitions we learned from S1. Okay. So anyway, when it comes to a binomial distribution, you need to know the mean of a binomial distribution is found by NP. So what is N and what is P? N is the fixed number of trials. P is the probability of success. And the variance of X is found by NP times 1 minus P. Okay. So you can directly use these equations in the calculations. You can directly use this to get the mean and the variance. Okay, so let's go for some sums. Okay, so we'll move on to exercise 1C and practice with some questions. They say x is a random variable such that x follows a binomial distribution with n12 probability of success 0.7. Find ex. So how do you find ex? Ex equation is np. So n is 12, probability of success 0.7. 12 into 0.7 is 8.4. And let's get the yx. So what is the equation of variance x? Variance x is np 1 minus p. Directly use the equation. So n is 12, probability of success 0.7, 1 minus 0.7. 12 into 0.7 into 0.3, right? 1 minus 0.7, how much is it? 2.52. Okay, so let's move on to a few more sums. So question number 2, they say x is the random variable such that x follows a binomial distribution with the fixed number of trials and probability of success 0.4, and ex is 3.2. Find the value of n. So how do you find the value of n? They have given you the expected value, right? So expected value is equal to what? NP. So expected value is 3.2. N is unknown, right? Because n is not given here. P, probability of success is 0.4. So n equals to 3.2 divided by 0.4. How much is n? N is 8. Part B, they are asking you to find the probability x is equal to 5. So how do you find the probability x is equal to 5? So you could, the n value here is 8. So if the n value is available in the cumulative distribution table, maybe you could subtract the two n values, the cumulative probabilities, and get it. Or else you could do this by using the formula manually. Okay, I think we have the n values 7 and 8. Okay, so actually we could do this by the equation also, right? The the binomial equation, NCX. So probability is NCX. In this case, it's n is 8, so 8c5, p to the power x. So p is 0.4 to the power 5 into 1 minus 0.4. 1 minus p to the power n minus 6. 8 minus 5, that's 3. So what is the answer? In the cal? We'll type this in the cal. What's the answer? So in the cal, you get the answer. So we get the answer 0.12386304. So give it to 4dp. 4dp 0.1239. Okay, part C, you have to find the probability x is less than or equal to 2. This, of course, we can do it from what? From the cumulative distribution table. So go to the n value 8. N value is 8. Okay, so we just found that n here is 8 over here, right? So 8, probability of success 0.4, and x value is 2. So n is 8. N is 8, probability of success 0.2, and the x value was also 2, right? Am I correct? Probability of success 0.4, x value is 2. Probability of success 0.4 and x value is 2. So we get the answer 0.3154. Is that correct? Probability is 0.4, n value is 8, right? Let me check again. Probability 0.4, x value is 2, 0.3154, right? Okay. Okay, so question number 5. I choose question number 5 next. X is the random variable such that x follows a binomial distribution n comma p. So none of the variables are given. Ex is 4.8 and variance x is 2.88. Find the values of n and p. So np equals to 4.8. np times 1 minus p equals 2.88. So so you can see here where, I mean, for ex I used np, for yx I use np times 1 minus p. Is that clear? Now all you gotta do here is what? Solve these two equations simultaneously and get the answer. How do you suggest, what's the best way to solve these two? Yeah, so you could substitute maybe the entire value of np. np is 4.8, or you could, if you want, divide the two equations. That's also another option. So any of these things are okay. So you can take the entire value of NP and substitute that over here. So NP is 4.8 times 1 minus P equals 2.88. So 1 minus P equals 2.88 divided by 4.8. How much is it? For 2.88 divided by 4.8 is? Let's divide it. 0.6, and I get here 1 minus 0.6 equals to P. 1 minus 0.6 is 0.4. P is equal to 0.4. So they're asking us to get the P value and the N value. So get the N value. NP equals to 4.8. P is 0.4 equals 4.8. N equals 4.8 divided by 0.4. So 4.8 divided by 0.4, and the answer is 12. The answer is 12. Okay, so next let's move on to question number 6. They say the probability of obtaining a head when a biased coin is tossed is P. So it's a biased coin. And where P is less than half. So which means the probability of obtaining a head is lower than half. An experiment consists of tossing the coin 20 times and recording the number of heads. So what are we doing? We are recording the number of heads. So basically they have described you the random variable. X is the number of heads in 20 tosses. Okay, so then X follows a what distribution? Binomial distribution. We are tossing this 20 times. So fixed number of trials is 20. Probability of success is P, because they have told us it's an unknown value. Okay, it's a biased point. So in a large number of experiments, the variance of the number of heads is found to be 4.2. So variance is what? Variance X is given to be 4.2. Estimate the value of P. How do you estimate the value of P? Variance X is NP times 1 minus P equals to 4.2. So N value is 20. 20P times 1 minus P equals 4.2. So P into 1 minus P equals 4.2 divided by 20. How much is it? P minus P square. 4.2 divided by 20 is 0.21. So I get a quadratic equation. I get here P square minus P plus 0.21, right? P square plus P plus 0.21. Okay, so let's try to get the answers here. So if you type ABC in the cal, I think you get the answer as X equals, you get X equals 7 over 10, 0.7. And the other answer you get in the cal with X is 3 over 10 or 0.3. So now I'm going to perform factorization here. And I can see I can immediately factorize using 0.7 and 0.3. I don't need to use the 10 here. Okay, so this is not X now. We are making it, equating it to P. So we get here P minus 0.7 times P minus 0.3. Guys, I hope you can understand, because P into P gives the P square and minus 0.3p minus 0.7p is minus 1p, and I can get minus 0.7 into minus 0.3 is plus 0.21. So we get this perfectly. Okay. So in that case, I'm not going to take the 10 to the other side. So I can directly use this factorization, and I get here p minus 0.7 is 0. So which means p is 0.7. The other one, p minus 0.3 is 0, which gives me p is 0.3. What's the correct answer? I think they have given us a criteria about b. The p value. They have told us p is less than half. Therefore, p is equal to 0.3. This is clear. P is equal to 0.3. Okay, so we'll move on to part B. They say, hence, estimate the probability that exactly 7 heads are recorded during a particular experiment. So how do you find the probability exactly 7 heads are recorded? So you have to get the probability x is equal to 7. Simply get the probability x is equal to 7 by using the binomial formula. So NCX, n is 20, p x is 7, p to the power x, so p is 0.3 to the power x is 7 into 1 minus p, 1 minus 0.3 to the power n minus 6, 20 minus 7. So guys, let's get the answer. Type it in the cal. Okay, so the answer here is 0.164261. It goes on. So 0.1643, correct to 4 dp. Right, so this is the probability that exactly 7 heads are recorded during the experiment. Okay, so I hope this part is clear with all of you.